Okay, this problem says Stokes' laws describe sedimentation of particles in liquids and can be used to measure viscosity. So, for instance, if you wanted to measure the viscosity of an oil, so this problem shows you this how to do it. Particles in liquids achieve terminal velocity quickly. One can measure this time it takes for a particle to fall a certain distance and then use Stokes' law to calculate the viscosity of the liquid. So here's how you do that for oils. Suppose a steel ball bearing, steel has that density and diameter 3 millimeter, is dropped in a container of motor oil. It takes 12 seconds to fall a distance of 0.6 meters. Calculate the viscosity of the oil. Okay, so let's say you take a long glass tube filled with oil, you drop this steel ball, and it has reached terminal velocity, and the terminal velocity is given by the distance it traveled divided by time. So 0.6 meters divided by 12 seconds, and so the terminal velocity of this is, the steel ball is 0.6 divided by 12, 0.05 meters per second, and that's equal to 5 centimeters a second. Okay, 5 centimeters a second, so about 2 inches a second. That's the rate at which the steel ball is falling. Of course, we are going to use the SI units. Okay. Now, Stokes' law says, so when a ball is going at velocity v, so the drag force exerted by the liquid, the drag force is equal to 6 pi r, the radius of the object, times eta times the velocity. So that's the drag force. Now when the object has reached terminal velocity, the drag force is equal to the weight of the object, and that's why the object is not accelerating. So at terminal velocity, the drag force is equal to mg 6 pi r eta terminal velocity is equal to mg. All right, so if you want to find the viscosity, it's mg divided by 6 pi r vt. Okay, now in this problem, they do not give us the mass of the steel ball. What they give you is the density and the dimensions, the diameter. So let's write the mass of the steel ball is the density times its volume, and the density times volume, and the volume of a sphere is 4 pi by 3 r cubed. Okay, so we'll plug that in. Eta is the density 4 pi by 3 r cubed g 6 pi r r divided by the terminal velocity. All right, so this simplifies to the r cancels one of the r, so you're left with r squared. The pi cancels. This is 18. 4 divided by 18 would be 2 nines. Okay, so this would equal 2 nines density r squared g over terminal velocity. Okay. All right, so let's add a page below. So the viscosity is 2 nines, the density of the material which you drop, density of steel in this case, divided by r times r squared divided by the terminal velocity. Okay, again, let me draw this picture again. So what we're doing is to find the viscosity of this oil. For instance, you take a steel ball, drop it, it's reached terminal velocity, you measure the terminal velocity, measure the time it takes to cover a distance, terminal velocity, you know the density of steel, you know G, you know the radius, you'll have measured the radius of the steel ball, and so just measure the terminal velocity and you get the viscosity. Faster it's falling, lower the viscosity, that makes sense. Slower it's falling, higher the viscosity. Okay, so that's how you find the viscosity of oil, for instance. Okay, all right, so let's plug in the numbers, and this is equal to 2 times the density of steel is 7,800 kg per meter cubed. G is 9.8 meters per second square. The radius of the steel ball, so the radius is, the diameter is 3 millimeters, so the radius is 1.5 millimeters. Okay, so 1.5 into 10 minus 3 meters square divided by 9, and the terminal velocity was 5 into 10 minus 2 meters per second. Alright, so this is equal to, so here's what we'll do. We'll take care of powers of 10. So this is 7.8 times 10 to the 3. There's a 10 minus 3 squared. So we'll kill one of that, and then 10 minus 3 is left. We'll say 50 times 10 minus 3, and that'll kill that. Okay, so this is equal to, anyway, you can do this 7.8 into 9.8 into 1.5 square divided by 9 times 50, and let's do the units now. There's a meter cube kills that, so kilogram by second square is at the numerator, and 1 of the second square kills that, so it is, the units will work out to kilograms meters per second. Okay, those are the units for viscosity, the SI units. So, and this number works out to, so the viscosity of this oil, 2 into 7.8 into 9.8 into 1.5 square into, so the viscosity eta is 0.76 kg meters second. Okay, so that's the viscosity of the oil. Okay, again, let me point out, greater the terminal velocity, lower the viscosity, and that makes sense. So faster it's moving, thinner the fluid, so to speak. All right, that finishes that problem.